This question is called application letters. It says you're sending job applications to 5 firms: Morgan Stanley, Lehman Brothers, UBS, Goldman Sachs, and Merrill Lynch. You have 5 envelopes on the table, neatly typed with names and addresses of 5 people at these firms. Of people at these 5 firms. You even have 5 cover letters personalized to each of these firms. Your 3-year-old tried to be helpful and stuffed each cover letter into each of the envelopes for you. Unfortunately, she randomly put letters into envelopes without realizing that the letters are personalized. What is the probability that all 5 cover letters are mailed to the wrong firms? So if you have like 5 envelopes, like 1, 2, 3, 4, 5, and 5 letters. 1, 2, 3, 4, 5. This is asking us what's the chance that every single one went to the wrong letter, like this, something like this. Like 1 went to 2, 2 went to 1, 3 went to 5, 4 went to 3, and 5 went to 4, something like that. Let's call this probability of, call this events where all go wrong. Call it events of F, or failure. So event failure occurs when, if we have the case where 1 goes in the right letter, then that means that it actually succeeded. So we got a letter in the right envelope, and so event failure could not have happened. So it's going to be 1 minus the chance of event 1, where letter 1 goes in the right envelope. Or if event 2 goes in the right envelope as well, we also did not fail. We got letters into the right envelope. So union that with event 2. Again, same with 3. Union that with event 3. Union event 4. Union event 5. So the probability of event failure is this. Is 1 minus the probability of the unions of events 1, 2, 3, 4, or 5 happening, which is the case where letter 1 goes in the right envelope, 2 in the right envelope, or 3 in the right envelope, or 4 in the right envelope, or 5 in the right envelope. Now, if you know the formula for union, let's call it like probability of event A union event B. It's probability of event A plus probability of event B minus probability of event A and event A and event B. So you add each event on its own, and then you subtract the overlap. So why does this occur? Because when you have 2 events like this, call this event A and this event B, we're saying, if we add these 2 events, so this plus this, we counted this portion twice. So we subtract 1 time we counted that middle intersection by subtracting. Now, if you extrapolate that out for 5 events, the union of 5 terms, it becomes a little more complex. So let's say we had like 3. Let's build up a little bit. So if we had 3 events like this, so that's event, call it 1, event 2, and event 3. We're building up, right? We have 5 events. So we counted event 1. We counted event 2, and then we counted event 3. So same principle goes, we write down, so the probability of event 1 or event 2 or event 3 equals probability of event 1 plus probability of event 2 plus probability of event 3. So far it's the same thing. Now, again, we subtract the intersections because we count them twice, right? So this is the intersection 1, intersection 2, intersection 3. So we subtract, I just put it in parentheses, factor out the negative sign, subtract probability of event 1 and event 2 plus probability of event 2 and event 3 plus probability of event 1 and event 3. So we took out the negative sign, we added them. You distribute that negative sign back in, it becomes subtracting, same thing. But the issue is we no longer count this double counting or this double counting or that double counting. But the issue is now we never count this middle part ever, because we subtracted every time that intersection among intersections was counted. So now we have to add back that middle portion. And that means we add back the probability of event 1 and event 2 and event 3. All right, so we have like our foundation for this question now. So let's address this part right now. So probability of event 1 or event 2 or event 3 or event 4 or event 5. So firstly, we add up, call it the summation, from I equals 1 to 5 of probability of event I. So we just add up all the probabilities. Then, now what? So now we have to subtract I. We have I and j, where every time when j is less than I, for all j less than I, every time they intersect. And then we add back I, j, k for all I less than j less than k, their intersections, and so on. Then we subtract the case of 4, and then we add the case of 5. Now for this question, what does that mean? We have 5 envelopes and 5 letters. So the chance of, here, probability of letter 1 going to the right spot is 1/5. Letter 2 in the right spot is 1/5, 1/5, 1/5, and then there's 5 of them, right? Because there's I equals 1 to 5. That equals 1, right? This portion, what is it? The chance of 2 letters going in the right slot, any 2 letters, it's 1/5, right? Times, so that now that letter's in the right spot, there's 4 letters left, and 4 spots, right? So it's 1/4 chance for that the next letter goes in the right slot of the remaining 4. But we have 2 letters, so for all j less than I, there is 5 choose 2 ways we can have any letters go in the right slots. So 5 choose 2. Now if you simplify this a little bit, the formula for choose is, it was 5 factorial over 5 minus 2 factorial times 2 factorial, right? And this becomes 5 factorial under 5 minus 2 whole thing factorial. Okay, and we can see that we can multiply them. This 5 factorial cancels. This 5 minus 2 factorial cancels. So we are left with 1 over 2 factorial. Now this applies with all of them. So the next one, where we have 3, becomes 1 over 3 factorial. The next one is 1 over 4 factorial and 1 over 5 factorial. We have 1 and 1 over 2 factorial. And we say we alternate, subtract, add, subtract, add. Subtract, add, subtract, add. Okay. So what do these terms become? So 1 minus to 2 plus 1 over 6 plus minus 1 over 4 times 3 times 2. That's 24. And I think 5 times 4 times 3 times 2. That's 20 times 6. That's 120. 2 factorial times 3 times 4 times... Okay, that makes sense, yeah. Simplify that a little bit. You get 120 over 120 minus 60 over 120 plus 20 over 120 minus 5 over 120 plus 1 over 120. So 60 over 120 plus 20, that's 80. Minus 5 plus 1, so minus 4. So you get 76 over 120. Divide that by 4, you get 19 over 30. And no, that's a chance of at least one letter going to the right slot. And we said it was, event failure was 1 minus that. So 1 minus 19 over 30 is 11 over 30. And that is our final answer.